It's 10 o'clock, so let's get started. We're going to switch gears today. I'm going to talk about policy instruments. That is, assuming that policymakers, politicians have agreed on a target for environmental policy, how do you actually get there? What does the regulator need to do? And today I'm going to talk about 3 chapters there. I'm going to talk about direct regulation, command and control. I'm going to talk about voluntary agreements, and I'm going to talk about the Coase Theorem. But before we do that, there is one issue. Until last week, or maybe 10 days ago, I thought that this was our schedule, that spring break was between weeks 9 and 10, and then Sonja and later Shalong alerted me to the fact that this is wrong, that spring break actually comes a week earlier. Now, that has the implication for you guys that the essay is due in 4 weeks' time rather than in 1 week time. So that's good for you. It also changes the schedule because I was planning on doing 3 weeks on policy instruments. But with the spring break moved, that third lecture on policy instruments, which is typically the one that is least popular with students because it's about information asymmetries, because it's about monopoly power and all those sort of things, it gets pretty hairy. And the old schedule actually left very little time for preparation for the exam. So I think that this is a better schedule, that spring break is not something that I can set, right? So it will really start after week 8. That we skip the third lecture on policy instruments and swap it for preparation for the exam. This is different from what I promised in the beginning, but I think it is a better schedule. Now, of course, you have the right to keep me to my promises, so if somebody wants to protest, then we can switch back. But I think this is better for you. It does imply additional work for me, but that's not your concern. Any questions, comments about this? No? Then let's look at policy instruments. I'm going to start with an introduction, obviously, and that includes a couple of chapters. And the first one, a couple of sub-chapters. The first one is, why would a government intervene in the first place? And economic theory is actually clear about this. And has been since the days of Adam Smith, who realized that as soon as you have public goods, sort of the market will not deliver the Pareto optimum. The invisible hand will not work, in Smith's parlance. A bit later, Coase and Mill recognized that market power would also mess up the Pareto optimum. Coase was interested in market power per se. Mill was interested in natural monopolies, where the cost of providing competition is higher than the benefits of competition. And one example would be the road network. Another example would be the power grid, right? Marshall realized that there were such things as agglomeration externalities, or agglomeration goods, or spillovers, where you see companies clustered together and then they jointly are able to hire better workers, all of them together, or knowledge spills over from one company to the next. Pigou was also very interested in that, but did sort of recognize that there were also such a thing as what we would now call externalities. And then the latest addition to this is Akerlof's asymmetric information. And his famous Lemons paper. And all these are good, solid economic reasons for the regulator to step in. You don't need to be a communist to believe that the government has a role in the economy. A hard-nosed liberal economist would say the same thing for these 6 reasons. Of course, many markets display multiple market imperfections, right? So often there is a number of these things going on. And for instance, a lot of the environmental problems, that is externalities, come from the energy sector. And as I said, the electricity grid is a natural monopoly. But because of increasing returns to scale in power generation, there's also a lot of market power on the power generation side. And therefore you have these 3 components, these 3 market imperfections interacting with one another. There is also an improper reason for the market, for the government to intervene in the market. And that comes under the heading of rent seeking. That is, politicians may want to distort the market so that their political allies or their political donors can corner the market and make excess profits, or they may want to distort the market to reward those people who voted for them. And there's plenty of examples like that also in the environmental arena. What you see, for instance, is subsidies for electric vehicles. The way these subsidies are structured benefit 2 kinds of people. One is Elon Musk, right? Because a lot of these subsidies actually flow to the car manufacturer. And at the moment, Tesla is still the dominant firm. But also, if you look at the structure of these subsidies, they are often co-subsidies, and they're often subsidies on the purchase of the vehicle. And that means that essentially you're rewarding those people that would have the additional capital themselves to buy an electric vehicle, which is still fairly expensive compared to diesel and petrol engines. So they are typically bought by people who are relatively well-to-do, and as soon as you give a subsidy for the purchase of these things without really leveling the playing field with internal combustion engines, you essentially give a subsidy to people who are relatively green, people who are relatively wealthy, people who tend to live in cities, that is, people who tend to vote for the Democrats in the United States. And we see similar things happening across Europe, not so much in this country. Although if you look at the subsidies for solar panels, which are introduced by a Tory government, they primarily go to rural homeowners. That is, people who primarily vote Tory. And you can sort of like see these patterns that subsidies are introduced to reward the people who voted for the government. And that is, of course, an entirely improper government intervention, but unfortunately all too common. So those are the reasons to regulate, and also a reason not to regulate, to be very cautious with regulation. Now, what can the government do? And unfortunately, unfortunately for you guys, a government can do a whole lot of things. I'm going to talk about all of them. I'm going to talk today about direct regulation and all the forms of some of the forms of direct regulation that are there. I'm going to also talk about the institutional instruments, and then next week I'm going to talk about the market-based instruments. the government simply has a large number of tools at its disposal to intervene in the market, and it's using all of them, and therefore we need to go through all of them. In deciding what instrument to use, the government has to understand the problem it is trying to solve. And that depends on the type of pollution that we're talking about. So we talked extensively about stock and flow pollutants, so I won't go into them again. The medium, the environmental medium where the pollution takes place actually matters. So previously I talked about acid rain, which is something that is in the air and therefore is blown with the wind, and it can end up anywhere. And acidifying substances, sulfur, actually can travel for thousands of kilometers. Whereas if you're talking about soil pollution, like there's an incinerator that did not burn your waste at the right temperature, you create dioxins, they land in the soil. That is very carcinogenic, very dangerous substances, but very localized. So if that is your problem, you can solve it by building a fence around the polluted piece of land. You can't do that with sulfur, right? Because it just blows in the wind. Similarly, if you have water pollution in the river, that just flows downstream, right? Air pollution can blow in any direction depending on the wind. Water pollution flows up from upstream to downstream. So you know at least the direction of travel. If you have a few point sources of pollution, say you're worried about nuclear waste, that is on the one hand it's a complicated problem, on the other hand it's a simple problem because there's fewer than 500 nuclear power plants on the planet, and they use 3 or 4 different technologies supplied by 3 or 4 different companies. So that is a problem where a technocratic solution may actually work because there's only a handful of companies that you need to talk to in order to solve that problem. If on the other hand you're trying to regulate the emissions from cars or the emissions from farms, there's tens of millions of farms, hundreds of millions of farms probably, and there's billions of cars on the planet and billions of drivers. And that simply makes it much, much more difficult to coordinate the solution, makes it much more difficult to account for all the diversity in the use of a particular technology. Some problems are very homogeneous, other problems are very I can't say that word, very diverse, right? I talked about spatially concentrated and homogeneous impacts. You want to create a nature reserve, you want to create a nature reserve. If you're worried about UVB radiation, it is all over the planet, right? And that makes it very, very difficult. And of course, as a regulator, you also need to understand your mandate. We have local governments, we have regional governments, we have national governments, we have continental coordination mechanisms, and we have global ones. And similarly, we have environmental problems that span these scales. If you're worried about noise, talk to your county council, maybe even your parish council, right? Because they control these things, they control traffic, they control parking. They have nothing to say about energy. What you may have noticed is that there's a lot of cities that are getting very worried about climate change and their CO2 emissions. It's a nonsense, because this is driven by agriculture, which is basically outside the cities, so city governments have nothing to do with that, and it comes from power generation, which is under the control of typically the national government, not the city government. and most of the emissions from traffic come from long distance travel, not from the trips that you make within cities. So city governments have nothing to do with CO2 emissions, and it is just silly of them, or maybe it's a political gimmick, that they get so worked up about this. It is simply not their mandate, right? You're talking about a problem like acidification, as I said, can travel thousands of kilometers, but not tens of thousands of kilometers. So what you need here in order to solve it is a continental organization that solves it, like the European Union, which has been very effective in solving acidification problems. There is no equivalent in East Asia, and no equivalent in South Asia, which part of the explanation why acidification is still a problem over there, but not in Europe, because we have this we used to be part of that, this supranational organization that can take charge of this, right? So you need to understand both how things are governed and actually what you are trying to solve. And then when you make up your mind about what to do, you need to have criteria for saying, well, this instrument is better suited for this problem than that instrument, which may be perfectly suitable for another problem. One such criterion is cost effectiveness, and I'll make that more precise later, which essentially means that you can meet your target at the lowest possible cost. Now, to me, it goes without saying that that is what you should strive for. That if you can solve a problem for £100 million, then you should not be paying £120 million for solving that problem. Not everybody agrees with me. If you go to the shop and you can buy the exact same pint of milk for £1 rather than for £1.50, you go for the milk that costs £1. I think that comes natural, but not everybody agrees with me. Some people define environmental pollution as a sin, and therefore we should punish the polluters, in which case you should maximize the cost inflicted on them. I think that's a silly way of looking at things, but there are people who reason this. But then still it would be a criterion. How much does it cost to solve the problem is important information when deciding what instrument to use. Administrative cost is another one. Some interventions are cheap to implement. Other interventions are very expensive to implement. A cheap one for the government is to announce a new rule. Then when it actually comes to enforcing that rule, it can become more expensive, because that means that you need to keep an eye on what is going on. And in case people violate the rules, you need to take some sort of legal or administrative action against the offenders. And that may become very costly. One thing that is fairly cheap to do is change the excise on products. And that's actually not cheap, but it is cheap because we have all the systems in place to levy all sorts of excises already. We have administrative systems for VAT, and we have administrative systems for excises on cigarettes, on alcohol, and so on and so forth. So all the sort of computer systems are already in place, all the payment systems from the customer to the supermarket or the shops who collect these taxes on behalf of the government, as well as the administrative apparatus for the shops to pass these revenues, tax revenues, on to the government, right? All those systems are in place already. So if you now say we're going to introduce an additional excise on fuel, that is a matter of changing a few numbers in a computer code, right? Or if you're going to introduce an excise on food stuff, that is already in the tax system. So it's actually very, very cheap to implement additional excises, right? Whereas if you want to go for tradable permits, this is an alternative way of pricing environmental externalities. A tax is one way and a tradable permit is another way. A tax is cheap because the administrative system is already in place. Tradable permits used not to exist, and at the moment in this country they only exist for carbon dioxide and a few other greenhouse gases. And that means that you need to set up a completely new administration. You need to create a system for trading, brokers, and so on and so forth, and that is simply more expensive. You also need to beef up your monitoring of your CO2 emissions. So administrative costs are important in all this and may actually force you to decide for one instrument over another. Environmental effectiveness is key, right? We want to clean up the environment, so coming up with instruments that sort of like look good on paper but don't do anything, that's a bad instrument. An important part there is enforceability, that you actually need to be able to do something about it. And that is not just in theory, but also in practice. So people have been complaining a lot about all the sewage in rivers, and part of that is caused by bad regulation of the water utilities, the water companies. But another part of the question of the problem here is that over the years the Environment Agency that is supposed to enforce this has been stripped of many of its powers and also has been stripped of much of its personnel that actually has the capability of taking a company to court. They simply do not have the in-house experts to do this. And some people say this is by design, to create this organization that on paper is very powerful, but in practice actually cannot do a whole lot. And that means that a lot of these rules are simply not enforced. Another example here is India, which on paper has the most beautiful and the most stringent environmental legislation in the world, but simply does not enforce the rules, right? So enforceability is obviously important. I'm going to talk next week about long-run effects and dynamic efficiency, where we have taxes and subsidies that behave the same in the short run but have the opposite effect in the long run. Flexibility and uncertainty are important. Definitely if you have sort of problems that have a longer lifetime and solutions that have a longer lifetime, you need to be able to adjust your intervention as you learn new things, as circumstances change. And some things are simply more rigid. Some policy instruments are more rigid than others. Others are very easy to change. And that is important if it turns out that the problem is much worse than you thought, or perhaps you discover that the problem is much less severe than you originally thought, and then you need to change gear and perhaps direction. And last but not least, what matters is of course also not just how much it costs, but also who pays and how the costs are distributed, right? And I'll talk about all these things at some length later on. Right, so let's look at our first set of policy instruments. That is direct regulation, and Gollum sums it up nicely that we as economists, we hate it. So, what is direct regulation? It's also known as command and control. That's the pejorative term that we use for this type of policy intervention. And it's also known more politely as prescriptive instruments. And it is by far the most common form of regulation, and definitely also of environmental regulation. And the reason for that is that this is what comes natural to lawyers. This is what comes natural to natural scientists, and these are the people that started environmental regulation back in the 60s and the 70s. It turned out that they were highly successful. The environment of Europe is much, much cleaner now than it was 40 years ago, 50 years ago. The same is true for North America. So those people who were young then and the pioneers of environmental regulation in Europe and North America, those people look back on their career and said, well, this worked. And by now a lot of them are retired. Some of them have died of old age even. But the people that they hire to succeed them people hire people who look like them typically, and we're sort of in this this momentum that we look at back at the past. This worked then, why not try it again? Which would be fine were it not for the case that environmental problems are completely different in nature now than they were 50 years ago. So the problem in the past was that we had a few large sources of pollution. So if you're worried about water pollution, and that is actually the start of a lot of environmental regulation, there was this one tannery on the River Thames that dumped all these chemicals into the river, and the only thing you needed to do was either close the tannery, actually because tanning went out of fashion anyway, or you needed to put strict regulations on what it did, and then the problem was solved. Those were the environmental problems then, that you had a few factories that had just created a whole lot of problems, and it was just a matter of stepping in and telling them to stop it. Now we have problems such as climate change, which comes from the food you eat and the energy you use, and the problem is that everybody eats and everybody uses energy. So you have 8 billion people to regulate rather than a few factories. So the nature of environmental problems has changed very much. Another difference is that climate change is sort of like this global thing, and it happens gradually and it affects everybody. It's all very diffuse. Whereas if the river catches fire, that is an acute problem, right? And it's immediately obvious that something is wrong and that something needs to be done. And because the nature of environmental problems has changed, that also means that the type of solutions that you pick should change. But that has not happened to the extent needed. So what does direct regulation do? Essentially, it tells you what to do, what not to do, how to do it. It essentially prescribes behavior. For this to work, what you need is that a regulator knows what is going on. Because essentially what you're saying is, you guys are doing it wrong, you should do it differently. And you can only give sensible advice if you know in detail what people were doing in the first place. So if you want to regulate a nuclear power plant, that is simple in this country, because they're all run by a single company, and the older ones use one particular technology, and now we're introducing 2 new power plants that using a different technology. But essentially in this country at the moment there is one nuclear technology, and in a few years' time there will be 2 nuclear technologies. So if you want to control that, what you need is somebody who understands nuclear engineering, or somebody who has the wherewithal to talk to nuclear engineers and work on a solution, right? that can work if you have a smart civil service and you have an homogeneous product. If you want to regulate what farmers do, then there are so many of them that you can't just put them all in a room and talk to them, and they do everything so differently that you can't come up with a one-size-fits-all solution for them because they're all different. And you actually don't really know what they're all doing because they're all private, they're all small companies, right? And they all don't all report all the things that they're doing, right? So what you need as a regulator is very substantial knowledge, which is easier if you have homogeneous producers, which doesn't happen anymore. Another thing here is that it's not just that you need homogeneous producers. Even if you have very diverse production and deep knowledge about what everybody is doing, then you still can run afoul of anti-discrimination laws. Because essentially the principle of democratic government is that you treat everybody alike, and you need to have a solid reason to discriminate. And so you can discriminate between pig farmers and cattle farmers because that's an observable characteristic, but you can't really discriminate between Farmer John and Farmer Jane if they're both pig farmers. And they may have very different practices, but legally you can't say, well, I'm going to treat him different than her, right? So not just because of knowledge, but also because of legal constraints, anti-discrimination laws, you actually have to treat everybody alike. What you can do with pig farms, and that actually has been done with pig farms, is that you treat big pig farmers with more than 500 head differently than pig farmers with fewer than 500 head, right? That is something that you can legally do, but you can't say this pig farm with 1,000 head is treated differently than that pig farm with 1,000 head. That is simply not allowed. What types of direct regulation are there? This is definitely not all the types that are there. You can regulate the input into production or consumption. So if you want to drive a car or if you want to buy a new car, then it has to meet certain fuel efficiency standards. It's actually not true. It is if you want to sell a new car, it has to meet certain fuel efficiency standards. If you get too few miles for the gallon, too few kilometers for the liter, then you're simply not allowed to put that car on the UK market, period. So that is a regulation of the inputs of a polluting activity. Staying with the automotive sector, if you want to sell a car into the UK, it must have a catalytic converter. You're simply not allowed to sell not just new cars but also second-hand cars without catalytic converters, and if the MOT catches you driving without one, then you're in trouble, right? You must have such a thing. The reason the reason that we have regulations for fuel efficiency is to reduce CO2 emissions. The reason that we have catalytic converters is to take out a lot of the air pollutants that used to create smog in London and in other places. A good thing about catalytic converters is that you can't have leaded gasoline through a catalytic converter because it messes up the thing. So that is the reason why we took lead out of gasoline, which was never done on purpose, but is actually very good because lead is very bad for your brain. So that is a form of direct regulation, right? You prescribe the technology that can be used. And there's many other examples. You can also make rules about the output. That can be for the product itself. For instance, if you want to sell toys in the UK, you cannot use paint that is carcinogenic if that toy is meant for children under 3. The reason for that is twofold. One, we don't like our kids to have cancer, and second, kids eat everything and anything, right? So if the toy is carcinogenic when eaten, then that is not something that you want to have your kids near, and therefore we simply said this cannot be sold in this country. You can also have regulations on the waste that is produced by an economic activity, and one of the rules that are in place in this country on power generators, on the plants that make electricity, is that they can only emit a little bit of sulfur for every kilowatt produced. It used to be free, they could emit as much sulfur as they wanted. Nowadays there is a limit on the amount of sulfur that you are allowed to emit, and that amount is falling all the time. So these are the sort of the 3 most common types of direct regulation, either on the inputs, on the conversion of inputs to outputs, or directly on the outputs. But there's also other types of regulation, for instance on the timing of certain activities. A number of airports have the rule that you cannot take off before 6 in the morning. And some airports also have the rule that you cannot land a plane after 11 at night. And the reason for this is that so that the people around the airport can have a decent night of sleep, right? So that's a regulation on the timing of economic activity. You can regulate the location of economic activity. So the South Downs National Park starts 200 meters from here. In the South Downs National Park, there are simply a whole lot of things you cannot do. You cannot use certain pesticides, you cannot use certain fertilizers, you can definitely not build a factory in the national park, right? Those things are allowed elsewhere, but not in this particular location. The green belt is another example of a direct regulation on the location of activities. And then finally, you can just forbid a certain substance altogether. And the prime example for this are the chlorofluorocarbons, or CFCs. These are the substances that create the hole in the ozone layer, and used to we have forbidden to make these things, we have forbidden to sell them, we have forbidden to buy them, and we have forbidden to use them, just to make sure all those 4 things are now illegal. And that means that a hole in the ozone layer is slowly closing. So those are the sort of things that you can do with direct regulation. And you can think of a million other examples, no doubt. So let's return to our criteria even, and look at the very first one, and that is cost effectiveness. And I'm going to make this a little bit more precise, and show why direct regulation does not work in this place, in this case. So this is work that goes back to William Baumol, who you see here, and the question is, how do you meet a target at the lowest possible cost? So let's assume that the costs of polluter n, cost C of polluter n, are a quadratic function. So it's beta m times half plus half times gamma m squared. And this is, of course, for mathematical convenience. M is the amount of emission reduction. Not the amount of emissions, but the amount of emission reduction. If they don't cut their emissions, they have no costs of emission reduction, right? If M is 0, then C is 0. So these are the individual polluters. For society as a whole, what we want to do is minimize the total cost. So we sum over the costs of all polluters. But of course we don't just want to minimize that cost, we also want to meet an environmental target. That is, we want to make sure that total emission reduction, the sum over all m, n, is greater than or equal to our societal target m without subscripts, right? So what we're saying here is it doesn't matter who pollutes. What matters is the sum total of pollution. We have set a target for that, and then we want to reach that target at the lowest possible cost by minimizing the sum of all costs over all polluters by choosing their abatement level, right? By choosing the m sub n of all companies. So, in order to solve this problem, we form the Lagrangian, right? So that is simply the objective function minus, or plus in this case, it's a bit weird, the shadow price of the constraint, lambda, the Lagrange multiplier, and then the constraint itself, m minus the sum over mn. Right? This is simply optimization on the constraints. Then we form, then we take the first partial derivative of the Lagrangian to the things that we choose, to the things that we manipulate in order to maximize. So the LDMN. Now that is why we use the quadratic function, right? So first partial derivative of this thing is beta. First partial derivative of this thing is 2 times 1/2 makes 1 gamma m that we have here, right? And that should equal lambda. Minus lambda should equal 0. So the marginal cost, C sub m, should equal lambda. That's the first order condition, and this should hold for all n. And the insight really here is in the fact that this shadow price does not have a subscript. The marginal costs are different for all companies that have a different beta or a different gamma. The marginal costs are different, but because we only care about the sum total of pollution, we don't care about who pollutes. The shadow price is the same for everybody. So the first order condition is that the marginal costs are equated for everybody. That is the cheapest way of reducing emissions. And it immediately follows that this is very hard to do with direct regulation. Because the implication of this is on the next slide, that the optimal emission, the optimal emission reduction for company N is lambda minus beta over gamma. The emissions that each company should reduce is different for every company. Well, it's different if companies have different abatement costs. And this is very hard to establish with direct regulation, because you need to step in and tell everybody what to do, which is hard enough, because you can only get this right if you know the beta and the gamma of every company, of every polluter, which typically you do not. Maybe you have some approximation, but typically you do not have this knowledge as a regulator. But even if you would have this knowledge, you would not be allowed to come up with a regulation that is specific for every polluter. So even if you would know, you would not be allowed to act on this, right? And for this reason, cost effectiveness does not work in direct regulation. And then next week I'm going to show that it does work for taxes and tradable permits and for subsidies. What is the distribution of the costs? So what we have is, this is the first order condition. The implication is that your emission reduction is lambda minus beta over gamma. We can plug this solution back into the cost function to find that the costs of company N is this expression that you see here, right? Now, this does not mean a lot to you. So let's look at two companies, A and B. Both companies have a beta that is equal to 1, but one company has a shallow cost curve, gamma is 1, shallow marginal cost curve, and the other has a very steep marginal cost curve, and gamma is 10. And then what we can do is say, out of fairness, we say that both should cut their emissions by 1, right? And total emission reduction then is 2. For company A, because its cost function is so very shallow, that is going to set it back 150. For company B, that is going to set it back 6. And then the total cost is 750. So that's equal reduction. That is the sort of thing that you can legally do. That is the sort of thing that you can defend on the basis of fairness. If we equalize the marginal costs rather than the effort, then we would give company A 1.82, we would give company B 0.18, and the sum total is still 2, right? So the environment is just as well off. But the costs for company A rise to 3.5, for company B fall to 0.35. The total cost falls from 750 to 382. So really you see a very substantial cost saving for society as a whole. But you also immediately see that you have a lobbying problem here, right? Because one company prefers the first solution, equal effort. The other company prefers equal marginal costs. And the political game is then a political game, and God knows who will win this, right? But you see that there is a very substantial reduction in total costs. And then it's up to lobbying. Lobbying is a bit more complicated than you might think, because bureaucrats also play a role in this. And if we believe Niskanen, who you see here, then it may actually be a very substantial role. Because some forms of regulation are very simple to introduce. I told you previously that we already have a system of excises, so changing excises is very simple. It's a matter of changing a few numbers in a database, perhaps adding a line of code to an existing program. That's easy to do. And therefore you don't need many civil servants to do it. You may think that is a good thing, but if you are an ambitious civil servant, young and ambitious, you are in charge of a small part of the government bureaucracy, and you want to get a promotion, you want to extend your power, you want to hire more consultants, you want to hire more people who work for you, then you actually want to complicate regulations. Because if you can come up with a scheme that convinces people that it's wonderful, but would mean that your budget increases from £1 million a year to 10 or 100 million pounds a year, then that is excellent for your career. So it is in the interest of bureaucrats to increase bureaucracy. And then changing the excises is actually not a way to increase bureaucracy. Coming up with complicated rules that need enforcement, that need monitoring, that need long legal documents to explain what is going on, that is the way to make a career in the civil service, right? And that is one of the reasons why things get complicated. I promised that I would not talk a lot about climate change, but that's the area in which I work, right? And this example about sort of making rules complicated for God knows what reason is actually exemplified by the UK climate change levy. And these are real numbers. So the UK has a levy on the emission of CO2, but not really, because we don't monitor CO2, we monitor energy use. So the levy really is on energy use rather than on CO2. And there is a levy on electricity that is 0.008 pounds per kilowatt hour, which translates, or when the conversion was done, to or the emission intensity is 0.285, and this then means that the levy that is placed on CO2 emissions is $2.41 per ton of CO2. There's also a levy on gas use, and you see the price here. You see here the conversion factor to CO2, and that implies that the implicit carbon tax on gas use is only 10 pence per ton of CO2. And recall that the Baumol condition for cost effectiveness was that everybody pays the same at the margin for the thing that we care about, which in this case is CO2 emissions. But you see that power generation pays 24 times as much. It's not even close, right? But those climate change levies on gas have two exemptions. One is if your company has a climate change agreement with the government, then the charge falls from 340 to 75. That climate change agreement is essentially an agreement between your company and the ministry, the Department for Energy and Climate Change, the Department of DEC, it's called. If you have such an agreement, then you pay the reduced tax. The problem with these agreements is that the companies in there promise to do additional things that are good for climate change. These are confidential agreements, so we have absolutely no idea what is in them. What is clear is that this creates work for civil servants, right? You can have a bespoke agreement with every company. So if you're a lawyer working for DEC, this creates a lot of work for you. So that is one exemption, and again we're violating Baumol, right? There's another exception. Why is this thing now stuck? Well, it doesn't matter. That is if you're under the carbon price support regime, which applies for gas that is used for heat and power, then you pay, instead of the 339, you pay 331. Again, sort of messing up the criterion for cost effectiveness, that the marginal costs are the same for everyone. And then of course this is not true. Large installations also fall not under the EU ETS but fall under the UK ETS nowadays, which is the same but with a different name after Brexit. Which introduces yet another price distortion, right? So theory is clear. If you have a target, you want to meet it at the lowest possible cost. Make sure that everybody pays the same at the margin. In practice, we very regularly deviate from that, even if we use price instruments. And one of the reasons is bureaucracy getting in the way. We have 2 chapters left, and we're gonna do that after the break, and we're back at 11:05. Okay, see you guys then. 45 minutes and 2 chapters left. Let's talk about voluntary agreements. What I've argued before the break is that environmental regulation definitely, when things are very diverse, requires a lot of knowledge, and that may not be at the disposal of the regulator. So what you could do as a regulator is actually try and acquire that information in an exchange with the industry that you're trying to regulate. And as a result of this exchange, the rules may be laid down in what is known as a voluntary agreement. Now, this is not really voluntary, because typically these negotiations between the regulator and the polluter happen against the background of the regulator deciding to regulate nonetheless, right? So there is always a stick behind the door to do so. Good thing about voluntary agreements is that they would make use of the information within the industry about how to best clean up the environment. The bad thing is that these are negotiations that take place behind closed doors, and we don't know what is agreed. And before the break, I talked about the climate change agreements. Those are confidential contracts between the Department of Energy and Climate Change and the companies that sign these contracts, and we, the public, do not know what is in them. And that is just not we, the public, but also me, an academic, just doesn't know what is in these agreements. So there is directly, immediately a problem with public acceptability of these things. Now, we can make this a little bit more precise. Let's consider the following diagram. So on this axis we have abatement, that is now A rather than M, sorry about that. Here we have the marginal benefits and the marginal costs. These are the marginal environmental benefits. So this is what it would bring to reduce emissions. At this point here we have solved the problem. So there's no further gains to be had, environmental gains from cleaning it up. That is of course an assumption. And here we have the original situation where there's a lot of damage done. There's a lot of damage done at the margin. Now, the difference between sort of mandatory regulation and voluntary regulation is that the mandatory regulation sort of ignores all the idiosyncrasies of the industry, and the regulator does not really know what they're doing. So the marginal costs are relatively high. That is this line here, CM. Whereas with the voluntary agreement, CV, the marginal costs are lower because you use more information. So that is immediately an improvement of total welfare. But the idea here is that in return for disclosing this information, industry negotiates a less stringent target. So instead of abating up to level AM star, we only abate up to level AV, right? So more information, but also less stringent regulation. Is this a good thing or a bad thing? Well, obviously the costs of emission reduction fall from this square to this square, right? So this is unambiguously good for the polluters. Is it good for the environment? Well, the environmental benefits of the original agreement, the mandatory agreement, is this area here, No, these are the costs to the environment, sorry. And in the new agreement, in the voluntary agreement, the costs to the environment are this area here, right? So the difference in the additional environmental costs from accepting the lower target is this area here. And this is a good thing for society if the this area here is smaller than this particular area here, right? All agreed? The way I tell this story is completely different from the way it's drawn on the graph, right? Which suggests that I'm talking complete nonsense at the moment. No, I actually got it right. If you then subtract the two, you actually get to this area here. These are the benefits, so these are the, these are the benefits from the mandatory approach, and these are the net social benefits from the voluntary approach. And then the question is, which one is larger? And the difference between the two areas is, of course, the relative size of this triangle relative to the size of this square that you see here, right? And that is what I was meant to say. And graphically it is obvious, but this is of course just the way we drew the graph. It is obvious that this is a net social benefit, right? Now, why would there be a voluntary agreement in the first place? And under what circumstances would we get there? For that we need to look at the decision tree. And the decision tree comes in 3 steps. And I find decision trees always very confusing at first sight. And I suspect I'm not the only one. But really it is just a matter of working through it in steps. So in the first step, the regulator needs to make the first decision. And the first decision is whether to offer a voluntary agreement or not. If not, we immediately go to step 3. If a voluntary agreement is offered, then the polluter needs to make a decision whether or not to accept this voluntary agreement. So that is the split that you see here. If a voluntary agreement is offered and accepted, then there is no step 3. Then the environmental problem is being solved. There is no reason for Parliament to act, right? But if no voluntary agreement is offered or the voluntary agreement is rejected, then Parliament can step in and say, we are gonna mandate regulation. There's gonna be a mandatory intervention. Now, parliaments are always unpredictable. So let's assume that there is a probability P of the legislation, the Parliament introducing mandatory regulation, right? And that can happen because no voluntary agreement was offered, or because a voluntary agreement was offered but rejected, right? So we have these 2 subtrees that are the same. Now, what are the payoffs for the company? And they're given here at the bottom line. If no voluntary agreement was offered or it was not accepted, but legislation was introduced, then it has to pay the triangle that I showed you before, the target that was set times the cost of that target, the unit cost of that target, so that is CMAM, sorry. And that is the same in these 2 cases. Of course, if Parliament does not act, then their costs are 0. Then there's no legislation, no regulation in the first place. If a voluntary agreement is offered and accepted, then their costs fall to from CM-AM to CV-AV, right? So that is the trade-off that companies need to make. And you see that trade-off here. They would accept the voluntary agreement if this condition holds. So we already argued that CV times AV is, I think the sign here is wrong, that CV-AV is smaller than CM-AM. Oh, but of course I flipped sign on both sides. That is why the sign is as it is, right? This thing is always larger than this thing. We already established that because I changed sign. So what matters here really is how large is the probability of legislation being introduced in Parliament, right? And making it through Parliament. If the probability is fairly small, then they should just ignore the negotiations, right? If the probability is very large, if the probability is 1, then they should go for the lower target and the lower cost, obviously, right? So that is the decision that the polluter faces. The regulator presumably acts on behalf of society. So what matters to them is the net social benefit that I sketched in the previous graph. And the net social benefit is this expression here, it's this expression here, and then again for them this condition holds, where again what matters to the regulator is their assessment of the probability that Parliament would act if they do not. If you put these two conditions together, you have sort of a space where in some cases it makes sense to go for voluntary agreement. It's in everybody's interest to do so. In other cases it is not. Right? So it may seem a little bit complicated, but when you think about it and work through it step by step, it actually works out relatively well. Now there's other reasons why companies may act voluntarily to clean up the environment. And there's 3 basic reasons to do so. One is that there's a lot of consumers out there that like to buy green stuff and they're willing to pay more for it. So oftentimes making organic produce is more expensive than what is actually also organic but has pesticides and stuff in and fertilizers. But if you can sell it at a premium, then those additional revenues may actually offset the additional costs, and then it's in your own interest to put this stuff on the market. So that is one reason. There's simply demand for that. There's also such a thing as negative demand, right? Boycotts. Sometimes consumers get very cross with a company and start buying the products of their competitors, and that is something that can really, really scare companies, right? If it happens at a large scale. Consumer boycotts are very effective, but also very unpredictable. Like sometimes they catch on and sometimes they do not. And oftentimes they target companies that are just as bad as the competition, but just happen to have bad press in that particular week, and then it just snowballs, right? But this is definitely a reason to put green stuff on the market. This is definitely a reason for companies to clean up their production and perhaps their supply chains as well. So the premium that you get from selling green products and the fear of consumer boycotts. The same may happen with the people who work for a company. And this is probably more important for prospective employees than for the current employees, but they may simply demand that a company cleans up its act. Now, you will face the decision in the not too far future. When I started studying, we went during the introduction week, we went through the group and asked everybody, why are you here and who do you want to work for after you graduate? And about 60-70% of my classmates said, I want to work for Royal Dutch Shell because it's a secure job, good wages, interesting work, right? Now, we repeated that round when we were about to graduate, and at that point in time, nobody wanted to work for Royal Dutch Shell anymore. The reason for this was not all the environmental stuff, bad stuff that they did, like in Nigeria and in the North Sea and everything, because all that was still in the future. But what had become clear at that stage was, and now I'm giving away my age, right, is that Royal Dutch Shell was very close to the apartheid regime in South Africa, right? They had acquired a very bad reputation, and as a result, none of us wanted to work for them anymore. Now, this is a real problem for a company. If you are sort of the company that everybody wants to work for, you sort of get first pick. You hire the best and the brightest, the best young talent. If you are the company that is shunned, if your employees sort of like no longer brag at dinner parties for whom they work, but sort of like mumble and do something for that is a real problem, because the quality of your workforce, definitely for a company as technocratic as Royal Dutch Shell, is a real problem, right? So that is another reason for companies to be green. And sometimes it is actually the company owner or the CEO that is really green and just steers the company into a particular direction. When Bill Ford V, I believe, took over the running of Ford company, he turned into very green type of motor company. It did not last very long. But when the previous boss of Unilever, whose name I now forget, took over, he is a genuine green, and he genuinely steered the whole company, and this is a very big company, towards greener production and greener products. So sometimes it's just the one man in both cases, or in the case of the central banking system, one woman that steers companies and organizations into a particularly green direction. Now, some of this stuff is real and some of this stuff is fake, right? So-called greenwashing, right? And that happens all the time. The example of greenwashing that is closest to home is this university. If you look at our website, then we have all these awards for being green. If you look at the website, then you see these pictures of the north end of campus with the green roofs and the nature reserve and the meadows that were introduced. The meadows were actually introduced to study those the flowers and the bees that settle on there. Nothing to do with greenery, it's actually a scientific project. And you see pictures of the solar panels that we have. And the university is very good at sort of like creating this green image. This may have been sort of the impression that was created for you as well when you decided whether or not to come here. It's completely fake, right? Yes, we do these sort of things. We have green roofs on a very small fraction of our buildings. We have a few solar panels, but they're definitely not as widespread as they should be. We still have those very old buildings with very leaky windows, right? Some of the seminar rooms we were in yesterday, the only way to sort of like keep them cool is because the heating is running all the time, is to open the windows, right? And heat the outside. Many of our buildings are very badly insulated. And if you look at the new developments at the east slope, these are not environmentally friendly materials. The way the planting is done is not at all good for the uptake of CO2 or for plant life or for insect life or anything. This is greenwashing, right? Greenwashing. Very successful greenwashing, because we are third in the UK for sustainable solutions, or we were last year. We're in the top 40 in the world for this sort of stuff, for teaching about the Sustainable Development Goals. And one of the things, as you may recall, was the third lecture, if I'm not mistaken, where I rushed through all 17 of them. That is the reason that we are in the top 40, or one of the reasons. It's pure and simple greenwashing. This university is not environmentally friendly in any imaginable way. Let's turn to the final chapter, Coase, which is one of my favorite topics, but I'll promise to keep it to 25 minutes. The Coase Theorem is named after Ronald Coase, who you see here. And essentially the Coase Theorem, well, the Coase Theorem is not a theorem, and it's not due to Coase, but what he argued in a paper in 1960 is that the social optimum can be established through bargaining between polluter and pollutee. That's the efficiency thesis, and the outcome is the same regardless of the initial allocation of rights. That's the invariance thesis of the Coase Theorem. The efficiency thesis is just the first welfare theorem, right? If you have a market that works, then it will find a Pareto optimum. The second welfare, the invariance thesis may, in your mind, sound like the second welfare theorem, but that is not the case. So in the second welfare theorem, so the first welfare theorem says that a market will find a Pareto optimum. The second welfare theorem says that you can rearrange the initial allocation, and then the market will find a Pareto optimum. The Coase Theorem says, or the invariance part of the Coase Theorem says, that the Pareto optimum that you find in the second case is the same as that you found in the first case. So this is a sharpening of the second welfare theorem. Now, that was very quick. How does this work? Let's consider a cost-benefit diagram. We have emissions on the horizontal axis. We have marginal cost, marginal benefits on the vertical axis. If there's no emissions, then there's very little benefits of emission reduction. But as emissions increase, then it becomes more and more worthwhile to cut your emissions. The marginal benefits of doing so increase. If emissions are high, it costs very little at the margin to cut emissions, but as we cut emissions further and further and further, it becomes more and more expensive to do so, right? That's the standard cost-benefit diagram that I showed a couple of weeks ago, and then the optimal quantity is Q star, and the optimal price is P star. Now, this is what the regulator, what a benevolent planner would do. Either impose a price P star or impose a quantity Q star. Now let's consider a different situation where there is no regulation and there is no regulator and it's a free-for-all. And the example that I prefer to work with is most of you guys live in some sort of apartment or a bedsit or something. You may have may share this with somebody else, but it's typically a sort of building with many people in, right? And now suppose that a new guy moves in next door and he plays the saxophone. And he's not very good at playing the saxophone and he likes to do so late at night, right? And he has quite a lot of stamina, so he just keeps going and going and going and going, and you want to sleep or you want to study or you want to do something else, you definitely do not want to listen to the 10th edition of the Pink Panther, right? So that is the situation. As I said, there's no regulators in this building, there's no rules, so really the saxophone player plays until he's exhausted and his lips hurt, right? Now, at this point, what can you do? You can't complain to the building supervisor because there are no rules and there may not even be a building supervisor. What you can do is go knock on your neighbor's door and say, can you please stop playing? I want to sleep and I'm gonna offer you £10 to please stop now, right? And suppose that we are somewhere here. You are so very, very annoyed that you are prepared to pay quite a lot for him to stop. At this point, he actually is getting tired of playing the same thing and his lips are hurting and so on and so forth. So he is, yeah, you give me £1, I'm going to stop now, but you are so annoyed that you're willing to offer £10, right? Now, this sort of bargaining continues and can continue and would be mutually beneficial until the point where your willingness to pay him, to bribe him to stop, is at the margin equal to his willingness to accept compensation for not being allowed to play anymore, right? You can't go beyond this particular point because here he is still quite enjoying the noise that he's making and you are not quite as annoyed yet, right? So you can't conclude a mutually advantageous deal here, but you can here, and this is actually the point where your trading stops. So in this case, where there is a right in the building to make as much noise as you want, a bargaining process would lead you to what is the social optimum, right? Now let's reverse the situation where there is actually, you are in a building where there is a proper supervisor and there are proper rules and you're not allowed to make as much noise, right? So your starting point is in this situation. But the guy has this gig coming up and he really needs to practice. So what can he do? He's not allowed to make noise, but he can come knocking at your door and say, please, 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 can I play the saxophone for half an hour? And I'm going to give you £10 so that you don't complain to the supervisor, right? Now, if you're somewhere here, his benefit of playing the saxophone is actually quite large, and your tolerance of the noise, you're not quite that annoyed after only 20 minutes of playing. So you say, well, if you give me £2, I'm happy to accept this. He really wants to do it, so he's happy to give you £10, right? So you can strike a mutually advantageous deal, and you can continue to do so, and he can continue to increase his the number of minutes that he's playing the saxophone until this point where your annoyance becomes larger at the margin than his enjoyment. And at this point, you cannot close a mutually advantageous deal here, but you can here. And you reach again the social optimum, right? So regardless of the initial allocation of the property right, do you live in a building where anybody can make as much noise as they want, or do you live in a building where there has to be silence? You reach the same situation, the same equilibrium point, that also happens to be the social optimum. That is the Coase Theorem. If the market is completed by assigning property rights, it will find the Pareto optimum, and the Pareto optimum does not depend on whether there's a right to silence or a right to make noise. Right? That's the Coase Theorem. There are key assumptions that I made. One is that there's no transaction costs. This bargaining between you and your neighbor happens costlessly and doesn't take any time. And nobody gets cross with anybody and there's no aggravation, right? There's no transaction cost. That's one assumption. And that, according to Coase, is actually the key assumption here. And that is really what the Coase Theorem is about. Another important thing is that you actually are both informed and you can negotiate your way and negotiate in such a way that all relevant information is revealed. Another key assumption is that money is changing hands, right? but the money that has changed hand does not change your preferences, or more precisely, income elasticities are zero, because in one case he has more income, in the other case you have more income, but that does not affect where your demand and supply curves lie. And there is zero loss aversion. The cost and benefit functions are not kinked at the point of departure. If those conditions are met, then the Coase theorem holds. Now, people have interpreted this in many, many different ways, and Coase himself has interpreted it in many, many different ways. One interpretation that is popular among the more right-wing analysts is that, well, if we can bargain our way to a solution, why do we need government intervention? That's one interpretation. I think that is wrong, because obviously this can work between you and a neighbor, but this does not work for a big problem like acid rain, right? That affects millions, tens of millions, hundreds of millions of people, right? You can't negotiate your way out of something that has so many players, right? So it applies to very small things. So that is one interpretation. I don't think it's the correct interpretation. There is a second interpretation, and that is the interpretation that won Coase his Nobel Prize of 1991, and that is that if there are no transaction costs, then you don't need a regulator. But if there are transaction costs, then you do. And if you think back in your standard microeconomics, and it's actually not just your standard microeconomics, but it's about 95% of economic theory, there are no transaction costs. People can just instantaneously buy whatever they want from wherever in the world, and it just shows up on their doorstep immediately, and there's no search costs or anything, there's no transport costs or anything. That is one of the key assumptions in general equilibrium theory. And if that assumption holds true, then you actually take away a lot of the justification for government intervention. And really what Coase's interpretation and the interpretation of the Nobel Committee was that the Coase theorem fundamentally undermines economic theory. It shows that this particular assumption is not just unrealistic, but it also has profound implications, because if you make this assumption, then a whole other part of economic theory falls apart, right? That is actually what won him the Nobel Prize. The third interpretation of the Coase theorem is that, this is just ivory tower stuff. This can never work in practice. Yes, I can draw a simple diagram that does this, but this is not how the real world works. So it's just an intellectual curiosity. That's the third interpretation. And that interpretation that is common is actually entirely wrong. If you run similar experiments, if you run similar situation in experimental settings, that is, you put a bunch of people in a controlled environment in a lab, then in general people behave as Coase predicted they would. And many of the fairly strict assumptions that I talked about can actually be relaxed, and Coase still sort of works. So there's by now a lot of experimental evidence that suggests, under specific circumstances this works. But that is a controlled experiment. Thus can we also see signs of Coase in real life. And there's two things there. One is the polluter pays and the other is the pollutee pays. And we've seen examples of both. The prime example for the polluter pays in Coase type of bargaining has actually to do with things that have been going on for a very long time in Western Europe. In 1931, the company Mines de Potasse d'Alsace, which is in the Alsace, and it's potassium mining, as you may have guessed. If you mine potassium, you need to clean them, blah, 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 blah. You create a lot of chlorides, and what they used to do is they just dump them locally. But in 1931, the locals protested so much that the company decided to dump the stuff in the Rhine instead, which is very convenient because the Rhine then flows to Belgium and Germany and then to the Netherlands, so the problem is solved, right, from a French perspective. So they started doing that in 1931. It's caused lots of problems with drinking water in the Netherlands, and 41 years later they actually agreed to start solving this. And the agreement in 1972 was that 4 countries would contribute to cleaning up the operations of Mines de Potasse d'Alsace, and here you see the cost distribution. Why is Switzerland there? Switzerland was also dumping a lot of chlorides in the river, and they said, well, we'd rather pay the French to clean up their factories than us forcing our companies to clean up our factories. And Germany made the same decision on the same grounds. So that was the agreement in 1971. In 1972, in 1991, the agreement was revised. Switzerland by then had closed half of its industry, so it's sort of half dropped out of the agreement. The Dutch contribution was essentially changed to zero because it was all diverted inland. And from 1991 onwards, it is basically the French and the Germans who pay to clean up this. And they're the polluter. It is not their problem, but moral pressure, perhaps the threat of a lawsuit, but really international law is pretty weak on this, so it's mostly moral pressure that essentially have France clean up its own act. And this was through a process of 1991, 60 years of negotiations. So transaction costs were definitely not zero. And at one point they started recalling their ambassadors, and there was really a big fight between the countries. So it was zero. It's definitely not zero transaction cost. But in the end, they did reach an agreement. Now that is the polluter pays. Typically, we are in a situation where the courts are involved, and that actually goes back to a ruling that was made by King John. And here you see King John as he looked when I was young, and this is how King John looked when you were young. And some people call this progress. So King John, of course, Robin Hood, of course, Magna Carta. But he also did other things, and one of the things that he did was, at that time the king was actually also the chief justice, right? A case came before him where Jordan the miller, who thought that his mill needed to work harder, so he needed a bigger reservoir, and what he had done was he had flooded the land of his neighbor, Simon of Merston. And King John ruled, this is not okay. And because of this ruling, which was made in the year 1201, in common law, the polluter pays. You cannot annoy your neighbor, right? Is essentially the ruling. You cannot create a nuisance for somebody else. It's called the tort of nuisance, because at that time this was still Norman, right? So everything was done in French, not in English. In 1938, a good bit later, a similar ruling was made by an international court when Canadian trail smelters created a lot of air pollution in Washington state. And at that point, an international court ruled that the ruling made by King John in 1201 doesn't just apply to neighbors who live in the same country, but it also applies to neighbors who live across the border, right? You cannot create a nuisance. Now, that implies that Coase is actually very hard to interpret in these sort of cases, because there is really, if you as a polluter don't clean up your act, chances are that you will be taken to court. So what we've seen, particularly in the United States, but elsewhere as well, that sort of chemical companies, power companies, prevent the problem by buying up entire neighborhoods, by buying out people's properties, sometimes entire villages. Sometimes they do this after an accident, sometimes they do this after a near miss, sometimes they do it because there is a real prospect of a lawsuit coming up, and sometimes they just think, even though they're not complaining yet, they will so in a year, so we better do this, right? So there's definitely a lot of cases where we sort of like see something that resembles Coase. It also can happen that actually the pollutee pays. And the prime example, so it is sort of, under common law, it is natural that the polluter pays because of the tort of nuisance, right? But we also see cases where it's the other way around. And the prime example in the literature is by Vittel, which is a brand now owned by Nestle. So this is mineral water, and you sell mineral water because it is so very, very clean and it doesn't have all the contaminants that you see in tap water. That is the selling point of mineral water. The problem with Vittel was that they had all these farmers very near where it drew its water, and they were using fertilizers to an extent that was legally allowed. They did not over-apply fertilizers, but definitely some of the fertilizers that they used leached into the spring water that Vittel used. So what they did was they essentially bought them out. They paid them to change their ways, to use less fertilizer, and actually paid very handsome sums to compensate them for their losses. Also gave technical support, and so on and so forth. And the pollutee pays here. Similarly, New York City had the choice between building a new water treatment plant, because there was so much polluting coming down the Catskill and Delaware rivers, which is where New York draws its drinking water. So that was one option. The other option was to buy up all the farms upstream and close them down. And New York decided that this was the cheaper option. This also happened internationally. Sweden and Finland have cleaned up a lot of pollution in the Baltics and in Poland. They tried to do the same in Russia, but they failed because first Yeltsin turned Russia into chaos in the Wild West, Wild East, and then Putin turned it into its current kleptocratic state, and it's completely impossible to do business in Russia. So they did not succeed there, but it did succeed in Poland and the Baltics, and Japan did the same around East Asia. Now, the example that I started off with was you and your saxophone playing neighbor, which is a one-on-one bargaining, which is very simple, right? But oftentimes you have multiple polluters or multiple pollutees, and if you think back the Vittel, we had one company and a few dozen farmers, right? And there the coordination was done by the company. But coordination can also be done in different ways. In Santa Maria, it was actually the local government that took up the role of the coordination. But you can also have NGOs doing this. These are two of the more progressive environmental NGOs in the United States, Nature Conservancy and Environmental Defense Fund. They hire very smart economists, and what they have done was they sort of had this multiple coordination problem. So there was a lot of people upset about fisher folk accidentally killing dolphins, accidentally killing turtles. And a lot of people were upset about that, but you personally cannot do a whole lot about that, right? And on the other hand, you have a whole lot of fishing companies, right? So what they did was coordinate the two sides. They sort of acted as an intermediary. They collected a lot of donations for people who did not like, or people who like dolphins, people who like sea turtles, and were willing to pay. And they collected all these monies and then made sure that the right people got compensated and changed fishing techniques. And sometimes they just bought out fishing rights and just bought up the fishing boats and then just harbored them. The same NGO did the same thing in creating habitat for migratory birds. So California, you have all these birds traveling from the Arctic to the tropics, and they stop in California in the wetlands that used to be there for feeding, and now these have all been turned into rice fields, and they are drained before the birds come, or that used to be the situation. And now Nature Conservancy has collected a lot of donations from people who care about migratory birds, and they use this in a reverse auction where farmers can bid. I will keep my paddy rice fields flooded until March so that the birds have a place to rest and feed, right? And they're coordinating this sort of like, it's not a bargaining between two parties, but there's a large amount of farmers and an even larger amount of people who care about migratory birds, and they sort of like take this intermediate position and coordinate these things. So, Coase, to sum up, it works in theory, actually sometimes works in practice as well if you're at least working in the right direction. The good thing about Coase bargaining is that it can sort of like reach into problems where it is very hard to imagine that the government can regulate. And that is a useful thing to have. That's all for this week. There's one thing I forgot to say. The seminar of Monday is again online, so I don't care where you are as long as you have an internet connection. Okay, I hope to see you guys then.